Can you guys see it?
Yep.
All right. So, hi everyone. We're group 16, and we worked on the Apple Watch Fitbit project. Our team is made out of me, Luis, Domingo, Alonso, and Sandron. And then just a quick overview of our project. Our goal was to build an application that allows us to have more control over our data, and more specifically, the heartbeat. In our case, we used an Apple Watch, an iPhone, and we used @sign to transfer data between devices. And then later in the presentation, we'll cover some of the use cases and some things that we can do once we have control of our data. But I'm going to pass it on to Sandron to talk about some of the tools we use.
Can you guys hear me?
Yep.
Okay, so these are the developing tools that we use. And we also use this. We also use wireframes to. So wireframes is a type of a rough sketch of the user interface. We use them to give a tangible idea of what the overall functional layout will be like. In the early stage of the project, we use Figma to help us design the pages of what users can see. We also transfer the code from Figma to Flutter. So in the later stage, it helped to frame out what each page looks like. So these are some examples of the final design. But unfortunately, we didn't have enough time to make the final product looks like that. But we did approach most of them because we spent most of the time on the other technical issues that we focused on. Yeah, so if we have more time, we could build a fancier page. So here's the, as you can see, the menu bar here. And we have this biometrics page. So basically we want the user to fill out everything on the phone. So it'll be only one page showing on the watch. Yeah, that's it. Do you guys want to add anything?
I think I'm going to do the demo now, right?
Yeah, that was pretty good.
Okay.
Yeah, demo time.
All right, so I have to share so I don't know if you guys can see my video, but there's the heart rate. It really is that high because I have the flu. So can you guys see my phone?
Yeah, we can see.
Yep.
All right, so I have to build the app after I share because this app, once I switched it over to Swift to get the functionality from the Apple Watch, it no longer ran in Flutter. It had to be run out of Xcode or else the app would break. So here we have the onboarding. You can see it's going to update soon. And it should be, yeah, there you go. So the Apple Watch is constantly sending the heart rate to the iPhone using @sign authentication. So I thought it was going to be slow since it has to go through everything, but because it's paired to my iPhone, it's actually instantaneous, as you can see when it updates. We also created the biometrics, and here you can input, your birthday, and it will save to your @sign. And I think if Luis wants to talk about this, he can touch on it more.
Yeah, no, this is pretty good. I think the main focus was collect some data to potentially have more accurate heartbeat detections or like workouts or stuff like that.
Yeah. So that's that is the entire application. You guys have any questions?
We have a couple more slides too.
Yeah, there's one more slide.
Yeah, I'll take over again. Can you guys see my screen?
Yes.
All right. So yeah, so we spent some time thinking about the use cases, and we realized that collecting the heartbeat and allowing users to enter their information was just the starting point for a real application. If we had more time, we would have tracked the heartbeat for a longer period of time. So maybe like 5 minutes or maybe 30 minutes, which would be like a workout. And then once we have enough workouts recorded, we could start displaying some metrics that are personalized to the user. And all of this is to make it like a more like a real app. And now I'm gonna pass it to Alonso to talk about some of the challenges we had.
Okay, for the project, we faced many challenges. First, we had to get good communication between all members of the team. For this, we tried to break down the responsibilities and talk through our Discord group to set all the progresses that were being done. At first, we encountered the problem that 2 team members were working in Windows and 2 were working on iOS. And yeah, so we had to set up the app working on both Android and iOS to make the progress. It was also our first time for all team members using Flutter and working with GitHub as a team. So we had to learn how to separate the code in different branches and make the merges without like messing up the main code. And yeah, those were the main challenges we faced.
So just to give an introduction, we are the robot sensor project. So our robot detects obstacles around it, and then it gives us a warning sign saying there's an obstacle that's close, you need to stop. We've also built in an LED that starts blinking as soon as there's an obstacle that is detected. For the future scope, I guess we thought we can put on some wheels and then make it more like a remote controlled car, and so that it deviates from the obstacles and everything. As you can see throughout this presentation, you can see that we do have a lot of problems, but we worked on it. We tried our best.
So I use 2 computers. I use my friend's computer so I could display both, show the camera of the Pico and show the VS Code. This is the setup that I have for the Pico itself. And this is the ultrasonic sensor. So what it does, it was one of the difficulties I faced is figure out how it exactly works so we could implement the code correctly. So what it does, it emits the sound that rebounds from an obstacle and returns back from one thing to another. And it calculates the time of the sound coming out and going back inside. So in order to calculate the distance, I created I multiplied the distance by 0.034. So it's basically dividing by the speed of sound, and then dividing it by 2. So you could, because it goes twice the distance, right? So you will get the distance between the sensor and an object. Okay. So I tried to use the LED RGB, but I think I received the malfunction one, so I just used an onboard LED to display whether the object is close or not. Okay, so I'm gonna run the code right now. while this is connecting, I'm just gonna say a few things. So it was also a little bit difficult to calculate which resistors we need to use. So I used 1K resistor, 1K ohm and 2.2K ohm together. So they created a voltage divider. So the sensor works perfectly without stopping. There was some issues with the pins, and sometimes they're not connected tightly. Does create some slow response. All right, so it shows the distance to the object, and when I place my hand, if you could see, I'm placing my hand right in front of the sensor. It starts detecting the distance to the object, and when I bring it closer, the distance should go lower and lower until it reaches 10 centimeters as I place the benchmark. And when it reaches 10 centimeters, the less than 10 centimeters, LED will blink on the Pico, if you can see, guys. And it will display a message, careful, the obstacle is close. Okay. So yeah, the same thing. And I can play with it. It's actually the response rate is very fast because I use the echo time or the speed of sound time. So it's very.
All right. So now it doesn't show, right?
Yeah, now you're good. Sorry.
No, it's all good.
All right, so to facilitate communication with the atPlatform, we set up two @signs. Both devices will be running on the @sign, one at the IoT device and one at the application. The Pico's @sign is called maximum computer, and the app's @sign is denoted as computer 0. The IoT device sends its data to the application and receives data from the application. So it is acting as both sensor and actuator. Going to the next slide, we have application @sign on the left and @server in the middle, IoT device on the right. After both @signs are initialized, app sends its data to its public key via the atPlatform. That's when app sends the data to the server, which is read by the Pico. After it reads the data, it realizes that the display text has been changed. So it displays the texts on the LED. And then it sends back the status signal across the server back to the application, telling that the text is displayed. So this is how the communication between the application and the IoT device is working. Nishika will walk you through the user interface design of this project.
Okay, so am I audible?
Yeah, we can hear you.
Okay, so we began with building the structure, the frame, the panels, the layout, the labels, and the buttons, as you can see on the screen. This was our first version. And then we went ahead and we worked on individual buttons and the display icon, which is on the top, as you can see. And in a couple of minutes, you'll be able to see the icon on the taskbar as well. And then we went ahead and added functionality to the buttons. Essentially, just printing text was our initial goal. So we worked on that. And then we added the custom input feature, as you can see on the screen. Next slide. We also added two LED assets to show off the on and off part of the display. So it acts as an indicator. So whenever there's a display on the LED board, this blinker also turns on. And next slide. Yeah, we restructured the positions of the button using a grid layout. So Java Swing isn't really compatible with other layouts. So we had to restructure the whole thing. And so we used the grid layout. And we connected button presses with the client communication at the end. And there were a couple of challenges we faced. So next slide. Oh, yeah. So this is our version 2, which you will see in a couple of minutes. And yeah, the challenges we faced were figuring out a compatible library to integrate the backend and the front end. So we went ahead with Java Swing to implement this. and there were a couple of mistakes in the layouts and the alignments because Java Swing isn't that flexible, and that was an issue to get the layouts right. So Java Swing also has a problem with accommodating basic components because we have to call multiple methods for just the basics. And yeah, like I said, we had a lot of flexibility issues.
And
And
yeah,
yeah.
that concludes our presentation portion. So if you're interested in any of the images we used, here are the links, so you can check them out. But yeah, now without further ado, we can get into our demo. All right. So to start us off, let's just connect and let me see if all right, yes, it's running. All right, let's quickly connect. See.
So while this connects, there's another point we would like to mention. So we use the public key as of now for the entire project, but our project is compatible with encrypted keys as well. But at the moment, for it to be faster, we use the public keys.
Right, all right. And that's just because of the PicoW's limitations. It would take much longer to use an encrypted key, but for practical application, that's what we'd use. And while this is connecting, let's just show you our UI. So we have 3 fixed text options, a text field for if you want to display custom text, and of course, the LED assets we mentioned before. And a lot of work went into making sure everything was right. UI-wise, as Nishka already mentioned, we added quite a bit to this. And, you know, this icon, I think is pretty neat. LED controller makes it look like professional application. So let's see, it's almost connected. Should be. Once we see data success, we should be able to send any of these text options. And simply, let me just also connect on my phone so you can see what it looks like. All right.
You may want to pin both the videos.
Yeah. Right. Yeah, can you see my phone actually? Or is it just
Yep, we can see here 6 sunglasses.
Oh, it's on me. Sorry. I meant to do it here. All right, now you should be able to see the LED matrix, right?
Yep.
All right, nice. All right, so now that we've connected, all you have to do to make this work is press any of these buttons. So say we press @, we just wait a bit and pay attention closely, because if you'll notice, once the text sends from our app to the server and is read from the Pico, there we go, it recognizes it. And now once it displays it, you see the text display on the LED matrix and the flash appears on the UI. And once it's over, boom, already updated. And another feature we added in between our last presentation and this one is that now we have a text display queue, which operates on a thread in JSwing. So if you do 1, 2, so we press 2 buttons, the second text option is in a queue. So once this text option displays, the next one will be sent after it. So let's see. UMass Boston. And there we go. LED stop flashing. And then it's going to do hello world. So quite a bit of functionality. Sorry if I can't see chat right now. If you guys have any questions, I'm all for answering them right now.
Sure, I have a question. What was one of the hardest parts about this project?
There are quite a few. I would say the hardest part was the UI. I think Nishka can correspond this like a lot. Just getting this layout working was difficult, even though it's simple. But also, oh yeah. Another aspect was the timing. So something we haven't shown yet, but I'll show it right now. Say you want to put in custom text, for example. Something we needed to make sure of was that whatever the length of the text was, we would stay flashing on the UI for as long as it was displaying. So we have we have to test numerous sorts of lengths, like very long text, shorter text, just to make sure that the display length on the LED and the UI flashing was synchronous. And, that took a lot of thread testing, made sure that the display queue was all good. So, it took both hardware and software expertise. And yeah, here you can see the custom text display option working.
Well done. So in your project, you have the app sending data to the Pico, but also receiving.
Yeah, so to further explain that, we can actually look into a key the @ being used. So as you can see at the bottom here, we're sending data from the Pico's @. And this happens after the app sends data. So what we do to make this all work is both the Pico and the app are initializing the previous @ public keys being used. The app key for our app's @ is called instructions, and our Pico's key is called LED. We read those in to know what they were before. And if they change, say the app clicks a button, @, what happens internally is the app key's value gets updated. So now it's @, but you are thinking, oh, but what if we did @ already? Would it just not send? Well, no, because we actually encode a special operation to make sure that if the text was the same before, it can still be displayed. And that's putting a space at the start of the word and stripping white space after it's received. So that just makes sure you can always display text whenever you want. And something we actually noticed during this, if you put text at the end of the key's value, it doesn't work because for some reason, when you send a key value that's the same as the previous one with the text with a space at the end, it'll retain the same value. But if you put it at the start, it'll update, which I'm not really sure why that happens, but that's the one thing that made debugging difficult at first. So like an example would be like if you put @ versus @ with a space, just it wouldn't really change it. I'm not even sure if it's a bug, actually. I guess you could call it a feature if you don't want spaces to matter.
We love us some bugs here. You can definitely raise that.
Yeah.
And there is a question in chat, actually. Colin asked if the Pico was polling the @ key.
All right, yes. It's polling, basically. So it takes a while for the Pico to get a public key. Like, it takes longer for even encrypted ones, but you basically have a loop that goes on and you're reading the public key value. And if that differs, that's when you know when to display. And we know that it's displayed when it tells the app that the public key for the Pico, the LED status has changed. We change between 0 and 1 using the XOR operation, though you could also put a conditional.
So our project was the IOMT heart rate monitor. I'll briefly go over the project summary, and then we'll do a live demo, and then we'll talk about more about the project. So for the project, what it does, it tracks the pulse and keep it under our own encrypted @sign. And in the beginning of the project, the professor gave us the components, and so we received some components where we also had some sensors. And what the sensor does is it collects the heart rate data and pulses from human body. And there are LED lights as well, which blinks according to the pulses. Then the Pico board sends the data to the app, which we created with the so many languages that we tried, which didn't work out, but we ended up with JavaFX. And then also, of course, to send the data, the Pico board needs to connect to the Wi-Fi. For us today, we're going to connect to the mobile hotspot because we're in the school and the internet is not that good. So, and then once we receive the data using the @send keys, we're going to show the data on our app, where we can manage and store the data, of course. And then also on our app, we have the smart tools where we can visualize and analyze the data using the graphs. And yeah, our project can work on, the real time, and then the result we can show remotely via mobile app or computers.
Hi, everyone. So we used the Raspberry Pi, of course, the Pico W. This is it soldered to the headers on the breadboard. This is also an LED, red LED on there with just one resistor that we used. And the main component besides the Pico W is the heart rate sensor that we used. So this basically emits an infrared light through this little LED here, and it has a receiver on the other end. It shines the infrared light through your finger and makes it so the light received on the receiving end generates a pulse, basically, depending on how much blood is in your finger at the time. So for this, I will just do the demo. So this is just the terminal that I just use for debugging. So it's connecting to Wi-Fi right now. It's a simple program, really. It's just sort of calculating the peak, which is the heartbeat itself. So while this is digesting now, I have my finger on the heart rate monitor, just waiting for it to start, and it'll give you a prompt to put your finger on the heart rate monitor. It'll give you about 5 seconds to do that. So just waiting for that now. For every frame, basically, it would compare different values, and if the new value was less than the previous value, that's how we know that there was a peak happening, where the number would rise, and then the value would rise, and then it would fall. So that's how we know the specific peak was happening for a heartbeat. And it happens twice for the heartbeat, because there is the systolic and the diastolic values, which would be the peak, and then there's a sort of secondary peak. So that will reflect on this. It'll look like there's sort of two heartbeats or two blinks happening, but it's really just one heartbeat thing. So it's telling me to put my finger on the sensor. It will show also a blink on the Pico W every time it detects a heartbeat. The terminal is just for debugging. So it looks like it's beating twice, like I said, but that's just for the different cycles. So it has the number 62, and that would be my BPM, and that is what is sent to Brian's app.
We decided to create a GUI to display the data between the two @signs. I thought it would be easy to incorporate the atPlatform with JavaFX. So it uses Java to handle the events, as well as XML and CSS for styling. So when we start the app, we're taken to the main activity where you have a choice to log in with a user's @sign and the machine that you wish to communicate with, or you can sign up and you'll be taken to a URL to sign up for an @sign. We're just going to click the sign in button. So it's the login activity. I just want to simulate the elimination of passwords to show, I guess, the simplicity of just using your @sign. So I'm just gonna use my own @sign and the machines. And so upon successfully logging in, you'll be taken into the dashboard. The dashboard's pretty simple. There's only really two functions. The start button, which basically prompts the app to prepare for the data being sent from the Pico, and then the save button, which allows the user to save the last measured heart rate to your own @sign that you logged in with, the self key. So I guess that accomplishes the tracking your pulse and keep it under your own @sign, your own encrypted @sign. So when you press start, it's going to fetch a calculated BPM from the Pico, which was 62, like we saw, and it's going to plot it on the graph. And so each session, it plots it on the graph to show some sort of average. And so when we save, it should give you a confirmation that the BPM was successfully saved to my own @sign. So, and it should show when I restart the app. So that's it for the application.
This is what the application looks like. So here we have two commands which will be sending to backend. One is open door and close door. And one is the status, which will be receiving from backend using Hall effect sensor. We are using two sensors. One is Hall effect and proximity sensor. And we have faced few problems regarding hardware, and we have few hardware constraints, which will be further discussed in this presentation. And how this app works and how the front-end and back-end operations are done will be explained by my teammates now. Thank you.
So the first thing that the user has to input their logging with their @sign. In this case, I used Acid Rock Money. That's @sign for the app. Then logs into the main UI. So at first, the status, it's basically blank because I haven't sent any data as yet. So, Yoshank, are you ready?
Yeah.
All right, so I'm gonna go ahead and hit the command to enter door to open the door. So basically, I'm going to send data to the server, which is the string 1, which it represents open, and the string 2 represents close. So I'm sending it now.
We actually did connect the sensor and the encoder, and after, unfortunately, when we soldered it, couldn't the computer couldn't recognize the Pico. Then yesterday we went to Mr. Fletcher, and then we had to take a new device and then redo our project. I'll just show you the this is when the door opens, the internal LED blinks for excuse me 3 times, and then when it closes, it blinks for 6 times. Sorry, I'm running down with cold, so. And then when it stops, it blinks for 2 times. Like when we use sensors, so to stop it, we used this command.
So this is the setup here.
Wow.
Yeah, it looks
That
very
is
complicated.
that's a
But that's
cool
because I put
setup.
everything together. So I have it running already, just so you don't have to wait for it to actually start up. So that's it starting. It's sending the data. So in our code here, we do all the stuff to connect to the Wi-Fi, and then we have the stuff for the detecting stuff for the Pico, like the inputs and outputs, and then we put the key into our @sign. So yeah, if this is the IR sensor, which is this one here. If it detects something, obviously it'll change it. So if I put my hand over it, eventually it's going to say obstacle detected. There you go. And then I'm just going to let it say it a couple times just so you can see it. And then this here, and all the wiring is the crash sensor. Now if I press that, you can see the LED lit on, and we can see the wait a little bit on the display, it'll change to crash detected. There you go. And yeah, and here's the beeper. It's mainly just for debugging. There's nothing really we could do with that. So you couldn't hear it because I have the silent one, but there's another one that's much louder, and I don't like to use that because it's honestly it's deafening a little bit. And then here is the knock sensor. We couldn't really do much with this because for some it has to be like pressed for really long for it to actually show up on the screen. Because I don't know if you can see it, probably not. Oh, there you can see the light. But for some reason, it needs to be on for like a long time for it to actually detect it. So yeah, that wasn't able to work. But yeah, the main ones are these two sensors, the crash one and the IR sensor.
We made an app for detecting collisions. It's very simple. I'll just run it. It basically just takes the data received from the Pico, and Ronnie has to trigger the obstacle. So we have the two types of collisions. We have the obstacle detection. If I click the button to detect for obstacles, if Ronnie moves his hand over the IR sensor,
Which
you
I'm
should be
doing
able to
right
see
now.
something. It takes a while.
Yeah, it takes a while, but yeah, there you go.
And it starts to
I
detect it.
yeah.
Now if I click the other button, we can look for a crash.
It should appear now. Okay.
There it is.
There you go. And
nice.
Yeah, you can explain the code, I guess. Yeah.
It's just Java Swing. It's kind of ugly to read, but it just makes a bunch of panels and puts them in a grid in the app. So the first layer would be the crash detection. The title would be here, and then we have two buttons. On an action, they look into the look for the data using a simple if statement.
Yeah, and we wanted to add to it to make sure, like, just so that when we put a hand over the sensor, it would just count how many seconds it does it. And then also for the crash sensor, it would just count how many times we have pressed it. So I guess, for example, if I press it again, because I think it's still on the crash detection button.
Yeah, it
if I
should
press
be.
it again, it should come up as 2. Yeah, now it's detected 2 times.